On Tuesday, I mentioned call stack. Before I move forward, I always want to ask students questions before I start lecture. So, how about you? What did we talk on Tuesday?
Tuesday?
Mm-hmm.
The memory allocate?
Memory allocate?
The principle of the operation system, like how they give software memory.
Okay, operating system gives software memory. And can you tell us more what happened on Tuesday?
The call stack.
Call stack, can you tell us a little bit more?
A function is called the.
Can you speak louder? Can you hear? Okay.
When function is called the following functions would be.
For a function is called, the statement after the function call will be pushed to the call stack. Okay. Can you tell us more about call stack?
It functions in the first and last out methods. So in the call stack, basically, if you have a function, you would have the line immediately after the function that is actually in the memory, like not a comment or something.
Okay.
And that would be taking that step. And then, so the program will go to the memory statement of the function, read it down, and then take the quotation from the call stack and go to that line and then continue.
Okay. Can you answer? What happens if a function finishes? What happens to a call stack?
No call stack.
Excuse me?
No call stack.
No call stack.
Yeah. I mean, the call stack is empty.
For one function returns,
The last
the top frame is popped. It's not the call stack becomes empty. It's just one frame is popped. When the function finishes, you may still have more
Oh, you mean
things in the code.
function? I thought program. Function.
Okay. When a function finishes, once the top frame in the call stack is popped, you may still have more functions, more things in the call stack. Okay.
Is it
I want to show
okay to
you
switch?
this example,
Is it?
how to see call stack in GDB.
Thanks.
Because very often when you debug a program, you need to know where the program comes from. You need to know which function calls which function. So before you use GDB, so GCC is a source code, it's a compiler. It looks at your source code. GCC does not execute your program. So what GCC can do is see what it can find in your source code. GDB is a runtime debugger. You cannot run GDB if GCC doesn't work, because if you don't have a program, GDB doesn't work. Right? So GCC takes the source code and create a program. And GDB runs the program. So you always have to run GCC before you run GDB. And you have to use -G so that GDB can work. Without -G, GDB cannot work. And Valgrind is also a runtime checker. Valgrind is not interactive. Valgrind tries to run your program and see what happens to your program. It does not interact with you. GDB will interact with you, means you need to put in commands as the program runs. So we first use GCC to compile. As I said before, -O means the name of the output file, and it will be an executable. It's a program the computer can run. Let's call it PA-01. By convention, an executable in Unix has no extension. Unlike Windows, you have exe extension. In Unix, there's no extension. To use GDB, you run GDB with the executable. Notice it's not the source code, it's the executable. If you have a multiple source code, in this case you have PA01.C and answer01.C, GDB will find the right source code for you. So you give GDB executable. Yes, please.
Does GCC have to compile it correctly with no warnings before GDB will work?
GCC, if you have warning, GDB will still work. If you have error, syntax error, GDB will not work.
Okay.
But you should fix warnings too before you run GDB. Okay.
What if we can't figure out why it won't compile? And why does
Well,
it
if
error?
the program cannot compile, GDB is useless. So you have to do certain steps before you get there. Okay. Actually, that's a very good point. Sometimes students they miss that, and then they have a program that was incorrect. Well, the program was somehow working before, so it passed GCC. So you get executable. You modify your program, it doesn't work anymore. So it doesn't generate executable. In that case, you run GDB, you run an old executable. And of course, you'll get very confused. You say, I modify something and it doesn't show up here because you don't have a new executable. So thank you for bringing that up. Make sure GCC, you pass GCC before you try to use GDB. Then when you start GDB, you will see some copyright and so on and so on. And this will tell you where the program is. You want to take a quick look. Sometimes students will have multiple versions in different directories. You shouldn't do that, but some people do. And sometimes they debug wrong programs. They may copy the file, say version 1, version 2, version 3, and you are debugging the wrong program. We'll talk more about version control, and that's the reason why you should not have a copy. You should not copy your program in multiple places. You should have multiple versions in the same place. B means breakpoint. If you go to this page, in the middle, it's breakpoint. You set a breakpoint so that the program will stop at the place you specify. So let me show you how to use breakpoint. You can use breakpoint in many different ways. What I am doing is the third way. I do breakpoint in the function name. You can set a breakpoint at a particular line. So you can say something like the following. You can say, I want to have a breakpoint. You can just use B, but if you want to use break, that's fine too. You can say, answer 01.c line 55. That will be line 55. In this class, I'm going to use this to mean 0. And this will be O. Just, that's my habit of separating these two. I'm not the only one. I've seen many people doing that. So 0 slash means 0. So you can have a line number. You can have a breakpoint and a function. So in this case, I say array sum. You can also say B, that will break at the line after the current line, and so on. So there are many different ways to do breakpoint. Yes?
If you break on line 55, will line 55 run as well, or will it stop before?
Okay. So his question is, if you set a breakpoint, does the program stop before running that place or after? The answer is before.
So it won't run line 55 as well.
You will run line 54 and stops before you run 55. Similarly, if you say breakpoint array sum, you will stop before running the first statement in that function. Sometimes you want to break some at a place, particularly inside a loop, but you don't want to do it over and over again because before there's a problem. For example, you call a function 1,000 times, and the function has a problem only when a particular value is, let's say, less than 0. So you can say breakpoint, and you can have an if condition there. For example, you can say if, let's say, length is 0. In that case, the breakpoint, even though you have a breakpoint, the breakpoint will be ignored if length is not 0. That way you can be more efficient in debugging. This is particularly useful when you know something is wrong but not always wrong. So you want to break in a particular condition, or you can obviously say length is less than 0 or something like that. Conditional breakpoint, it's very useful when you debug a big program. Any questions? Okay, so let me show you, I set a breakpoint in my function. Then you will say have a breakpoint at this place, in this file. Notice that I give executable, but you find the source code. And at line 6. To start running the program, the command is R. If you want to type RUN, that's fine too, but I'm lazy, so I want to type only R. Then the program will start running, and then you will stop at this line. Say breakpoint number 1 here. We'll talk about this number in a moment. And then you will stop before running this line. So for now, what's zero sum? Sum is garbage. I have said many times, you have to initialize variables because C does not initialize variable for you. So that further suggests the program stop before running the line. Right? Any questions? The next command you will very likely to use is called the next or end. So if you look at this page, you'll find end on this side, execution control. If you don't have this page, come over and still have a few more copies here. Okay? Next. Next means run a line and go to the next line. If I type print sum, it becomes 0 because when it stops at this breakpoint, as I said, breakpoint means reach before running a line. So sum has not been initialized yet. And say next means I run a line, and now sum is initialized to 0. And you will be in this line. And here, since it stopped before the line, it can be garbage as well. As you can see, index current is 8. Again, it's a garbage. You don't know what it is. Then you can say next. And then IND is initialized to 0. Okay. Any questions so far about GDB? Yes, please.
If you hit next and it's a function call, does it run the function? Or
I'll talk about it in a moment.
Okay.
Okay. Thank you for that question. You are just one step ahead of me. Any questions about this so far? Okay. His question is, if you hit next, and that next statement is a function call, what happens? So now I have to explain the difference between next and the step. So if you go to this document, you can see there's next, and there's a step. Here is the difference. If currently the program stops, add a statement, and if the statement, so stop means before running a statement. The statement is something like sum equal to 0, or x is 264, something like that. That will be a statement. A statement can be a function call. So if you call a function, if it's just one line assigning things, in this case, next and the step will be the same. If it is a function call, then next will run a function and then complete the function. and then go to the line, the statement, after the function call. So let me give you an example. If you have a function call here, let's say you have a statement called x equal to 5. The function call, it does something. And then another statement, y equal to minus 10. If currently the program stops here, oh, okay. Your program stops here, and you say next, then the program will be before y equal to minus 10. Means you run the function and you finish the function. That's next. However, if you do step, that will enter the function and stop at the first statement. In the function. I should zoom out a little bit. So to say it a different way, when you have a function next, you do next if you think the function is correct. You don't have to debug the function. You do step if you want to debug the function. Does that answer your question?
Yes.
Can you show that paper again? You do
This
step.
one?
Yeah.
So next means you complete a function. No matter how big the function is. You run a function, you go to the next line. So next, in this case, next will stop before y equal to 10, minus 10. If you say step, then you will stop inside the function. Yes, please.
If you use step and it entered the function and it stopped at the first statement, and then to continue inside the function, do you use next or step?
Depends on what's inside the function. The same rules apply. So if the first line, so his question is, once you step into the function, what to do next, right? Is that your question? It's the same. It apply the same rule. If a function, let's say the function inside the function, and here, let's say you have something like integer a equal to 16. In that case, step or next make no difference. If here you call another function, step or next follow same rule. Step will enter function 2. Next will run function 2 and come back here to the line after function 2. So the same rule applies.
If you keep using next after you enter the function, it will finish and go back to where it stopped at first before it entered the function.
No, you will not, because your function, if you enter the function, you keep saying next, you just keep going next.
Yeah, and
Until
then when this function finishes,
then you go back to
call stack?
the place where you should continue.
Okay.
Of course, if you have loop inside the function, you'll loop multiple times. Depends on how many times the loop goes through. Does that answer the question? Does everybody understand the question? Why you do once you step inside the function, as the same rule applies. Next, if you still have a function call inside, you run function 2, and then you continue to the line. If you have function 2, you say step, you enter function 2. There was not. Yes, go ahead.
Yeah, if you wanted to debug a loop, would you use step?
I'm sorry, can you say that
If you
again?
wanted to debug a loop, would you use step?
will I step inside loop? Depends on what you want to do. If you have a function call inside the loop, so if you have a function call, let's say you have a function call here. The question is, do you think this function is correct? If you think the function is correct, I will use next. If I'm not sure, I will use step. Because step will enter the function. Does that answer your question?
Yeah.
Yes.
If I say next and I go to the next line, and then I want to go back.
You cannot go back. Once you pass the line, you pass the line. You cannot go back to the program. Once you pass the line, you say, wait a minute. For example, here you do next.
Yeah.
And you find out, actually, I'm not sure the function is correct. Okay? Then in that case, you have to restart, run the program, say R. Use R to restart. And then here, instead of saying next, you say step.
Is there a way to repeat all the steps that you did in GDB? Let's say if you want to go back, I mean, tell the computer to repeat all the steps in the next and.
So your question is it possible to go to record what you have done?
Yeah.
I think so, but I have not tried, so I do not know the answer.
Okay.
Now here, you asked a question about loop. Now, let me just finish this. Conditional breakpoint becomes very useful, right? If you have a loop, and you loop 5 times, you say there's nothing wrong, and then you just say, okay, maybe I should introduce another command, is continue. Continue means you just run as far as you can until the next breakpoint. C means continue to the next breakpoint. If you don't have another breakpoint, the program will go all the way and complete. Okay? Now sometimes you debug, let's say you debug a loop, and you run a few iterations, you say, I think that's right. So you hit continue to the next breakpoint, and something is wrong before the next breakpoint. They say, well, I don't know what's wrong in between. In that case, you can set the breakpoint and come back again, but you have to restart the program using R. Does that make
Not
sense?
set a breakpoint after the function and have to start the program again, right?
If you set breakpoint after the function has exit, you have to restart the program. Yes. What's your question?
I was going to ask like how you get around your loop, because you probably don't want to hit.
How to get out of the loop? If you have no breakpoint inside the loop, or you say C, you will go to the next breakpoint. You can set the breakpoint at any moment. So after you get into, let's say this is a line 25, and you are inside the loop, and let's say this is the line 42. And you iterate a few times, you say, I think this loop is right. In GDB, you can say break line 42, and then you say C. GDB, and you say C. That way, the program will get out of the loop and go to line 42.
So it's a good idea to set breakpoints after loops then.
If you think the loop is correct and you want to get out, yes.
Is it okay if I just say B42, or do I have to say, give the file name and then say 42?
If you are in the same file, you don't have to give the file name. In that case, the 42, GDB knows you mean the same file. Of course, if something is wrong inside, then you may never reach 42. Because let's say something is wrong here, your program stops. Such as segmentation fault. You never had a chance to go to line 42.
And if that happens, then you have to just start with the line 25, and then you just
Yes.
keep going on until you find out where it
Yeah.
is
If your program never reached line 42, something is wrong inside, so you restart and then go over back here and see what happens there.
Oh, and in the paper they says can use comment counts after the steps next. Is that like how many loops can you?
Yeah, you can say, I want to ignore a breakpoint for so many times. So suppose you have a breakpoint, then you can say GDB, I want to ignore. So let's say I have a breakpoint inside. I have a breakpoint here. And the loop, let's say the loop iterates 1,000 times. If you have a breakpoint here, the program will stop 1,000 times, right? That's the definition of breakpoint. Inside loop, and loop goes 1,000 times. But for some reason, you think the first 100 times is fine. You say, don't stop the first 100 times. You can say ignore 100. That way, GDB will hit a breakpoint, and you have a counter. If the first time you encounter a breakpoint, you will not stop. The second time you encounter a breakpoint, you will not stop. You will stop after the 100 plus 1 time. Then you will stop. So ignore is a good command. Does that answer your question? Yes, please.
You say ignore 100 and then you run it.
Yeah. Then you say continue.
So it would ignore any 100 following breakpoints or just the ones, just the same one on this side?
I think it says here about ignore somewhere. The breakpoint? Yeah. Ignore breakpoint end. So before I talk about that, let me show you. In GDB, you can have a command called info_b, information breakpoint. That will show you how many breakpoints you have and the numbers.
Does it ignore the same breakpoint 100 times, or let's say just the loop iterated once and went to the next breakpoint? Does it?
Let me answer your question after I talk about this.
Okay.
Is that okay?
Yep.
So if I say info_b, it shows I currently have one breakpoint and it hit 1 time. Notice the number here, that shows the breakpoint number. I can set another breakpoint, let's say breakpoint line 41. So I have info_b. So I show there are 2 breakpoints. And the second breakpoint is in the function, array is increasing. I have not reached that breakpoint yet. So what you can do is you can say ignore breakpoint number 1 5 times. Does that answer your question?
I couldn't really get what you.
You have breakpoint numbers 1, 2, 3, 4, 5.
Yeah.
And you also say breakpoint number 1,
Okay. Ignore 5.
ignore 5 times. You hit breakpoint number 1, don't stop. Hit the breakpoint again, number 1 again, don't stop. You'll stop after the 6 times. After 5 times, you'll stop at the 6 times. Does that answer your question?
One more question. So, if the breakpoint 1, oh, okay. If I don't include that number 1 in front of the 5, so, oh, the syntax, okay. I'm sorry.
That's okay.
So, you can only use the ignore command that way? You can.
I only know that, that's the only way I know. I do not know any other way. Yes.
You said ignore 1 5 times.
Yes.
But if 1 is not in a loop, it's just at one point of your code, then
And
how
that-
would it, in one runtime it will ignore it only once, right?
Yes.
Then,
If that breakpoint is not hit 5 times, this breakpoint is meaningless. Right?
yeah,
Because you ignore 5 times, but you only hit once. So
doesn't make sense.
means the breakpoint the program will not stop. Does that answer your question? Any other questions?
So if we use it that way, that means you just like erase the first breakpoint.
You are not erasing, you just ignore a few times.
Every time. Right?
Yes. Now if you want to delete a breakpoint, you simply say delete 1. Now the first breakpoint has been deleted. Means if you continue running the program, it will not stop there even if it reaches that place. Yes?
You said you read one, does it have to be immediately after invoke or does it matter?
It doesn't matter. Delete one, you can say without saying info, but unless you remember, right? I don't remember which breakpoint I'm referring to, right? Now if you say breakpoint again, let's say number 7, it does not reuse breakpoint, so number 1 is gone. Now becomes 3. So if you set a few breakpoints, very quickly you don't remember which breakpoint refers to which number. That's why I use info B. Yes, please.
So GDB actually uses executable, right?
GDB use executable, correct.
Okay, so like, how does the program, how does it manage to decompile the executable to get all the code so accurately back out?
Okay, how does GDB know your source code? Is that your question?
Yeah, pretty much.
Okay, when you say GCC, you add minus G there. That will generate additional information for GDB to do. You can call it reverse engineering if you want to. Minus G will add the additional information. Minus G will make your program executable a little bit bigger and make your executable a little bit slower. But for this course, in majority cases, you don't care the program is a little bit bigger or a little bit slower. The more important thing is the program has to be correct. Once you are confident your program is correct, you replace minus G by minus uppercase O.
Override?
No, let me write it down.
What if you just don't use anything and write a new executable?
After you debug the program, and you are confident the program is correct, replace minus G by minus O is uppercase O. It's important it's uppercase, it's not lowercase. What does everybody remember what's lowercase? Output. Minus O means optimize. Your program will be a little bit smaller and it depends, maybe faster. Sometimes maybe 20% faster, sometimes maybe twice faster. Depends on how your program is written. Does that answer your question? Okay. I thought there's another question. Yeah, go ahead.
How does this work?
Yeah, what does it actually do?
Minus capital O.
Yeah.
Go to take course on compiler. You will look at, there are many rules. You will try to avoid these unnecessary things. And once you do minus O, you want to use GDB, you may get something very strange. You'll try to look at your code, minus capital O, will try to look at your code and see there are many rules, and there are certain rules that will make your program faster. And the program is still correct, but you can no longer debug. Okay. For this course, you don't need to worry. If you want to know what are the rules, take EC4CD3. I think it's 4CD3. It's the compiler course. Okay. Yes. I wish I could teach everything, but we don't have time. Yes.
And do we need to do this before we
For-
submit the homework?
For this class, for 2CD4, you don't need to worry about minus O.
Okay.
Okay. Don't worry about minus O in 2CD4. In 2CD4, just focus on minus G. Yes.
So for Valgrind, after you use it, like it gives you an output file, like a Valgrind log. So how do you get the output text file for GDB? Like how do you get that?
If you look at README, there's a way to do logging.
To
Logging.
get the log, okay.
Yes. Okay. Another thing. Thank you for bringing Valgrind. Valgrind does not work with minus capital O. You have to use minus capital G, minus G, lowercase. You use minus O and run Valgrind, you get strange things. Since minus O remove a lot of information and the Valgrind doesn't work anymore. Yes.
Also, like once you get like, what if you do Valgrind again and then you get another output text file or log file? Does it replace the old one?
I think replace the old one, but I think there's a way to do append.
Okay.
But you probably don't care about the old one
Yeah, I don't
since
want the old one.
That's an old program. If you change your program, you don't really care about the old one. Any other questions? Okay, so I have talked about quite a few commands. Continue, ignore. Actually, the ignore should have a breakpoint number. Sorry, I missed that. I talk about conditional breakpoint. You can say be if something. Like conditional breakpoint. To continue, you see information show you breakpoint, and so on. So GB is very, very useful. Of course, the ideal scenario is you write programs without bugs. That's ideal, but it's usually not easy. All right, any more questions? Let me show you one more thing in the computer, then I'll talk about code stack more. So currently, I can also have a command called list. This tells me, shows a few lines before and after the place where the program stops. And then if I want to see where the program is, I can use the command bt. bt is show, this sheet shows program stack. If you look at this page, in the middle, lower part, bt means backtrace. That shows you the code stack. And in this case, we see there are 4 functions starting from main at the bottom. Main function calls test 00 array sum, and that function calls test array sum, and that function calls array sum. So you see 0, 1, 2, 3. That means the 4 frames. We talk about frames on Tuesday, right? Every time you call a function, a frame is pushed to a top of the code stack. So 1, 2, 3, 4. 0, 1, 2, 3 means the frames. You can go to another frame by using the command F. So currently, the program always stops at frame 0. That's where the program is right now. So if you want to go to another frame, you can type F, let's say F2. You go to another frame, and that is at line 48 in PS01.C, as you can see here. And you can also type list. That will list a few lines in this frame. So this is the frame, this is the frame 2. And that is the line that calls the function test array sum. Yes, please.
So, so it called 3 different functions, and the frame is on the array sum right now, and it's in the array sum function. But when you go to the second frame, does the variables still hold its final value before it quits the function? Because when you quit the function, you know, the variables, they all get to.
Yes. You are, I would say, 30 minutes ahead of me. Can you hold on to that question?
Okay.
Before I get there? Okay. Maybe one lecture before ahead of me. Okay. His question is, what happens to the variables inside the function, say array sum? Let me go to frame 0. There are some, for example, I have a sum, I have int, I have some variables inside, right? If you go to frame 2, what happens? The short answer is they are still in your code stack. I'm only moving around the code, looking at the information. I'm not running the program.
Okay, my question is a bit different.
Okay.
When you go to frame 2, the integers, the variables that are in the frame 2, do they still hold their final value?
They hold the value when the function is called. First, I don't know how to mean a final value. This variable, let's say I change length 1 to len. Suppose I rename it.
Yeah.
Okay, so length 1, imagine length 1 is len, remove that 1. This length and the length in array sum are completely independent of each other, if that's your question.
I'll ask.
Imagine this length 1 is renamed called length. This length and this length have nothing to do with each other. They just happen to have the same name. So imagine, actually we'll talk about that. Imagine two families of the same last name living in two different houses. They very well do not know each other, right? So they occupy different memory space. Yes.
Over here you move from frame 0 to frame 2, right? And then you said you can go back to frame 0. So then if I do go back, can I continue debugging from where I left off?
Yes, you can go back to frame 0. Now, the program is not running right now. You are just moving around, see how the program stops. Because sometimes you are debugging a function and the function is not wrong. It's the coder is wrong. The coder gives garbage to the function. So you want to see the coder. Okay. Any other questions? Yes.
So, if we comment use the frame and then we move from frame 0 to some other frames, and if we run from there, like press out from right there, then is GDB will start from the frame 0 until the frame that we are right now in.
GDB will only deal with frame 0. If you want to run a program, now I'm not running the program, I'm just moving around, looking at the status. I'm not making any change to a program.
Anyway, if I press run, they will
If you press run, you will go. If you press run, you will start from the beginning. R will start the program from the beginning. If you press C, you will start from the place where it stopped right now. If you type N, you go to frame 0. Because frame 0 is the place where you are right now. You use frame 1, frame 2, frame 3 just to look around. Does that answer your question?
Yes.
Okay, yes please.
If you hit frame 2 and then hit continue, it's not going to start from frame 2.
It will not start from frame 2. It will start from frame 0 because that's the place where the program starts. Yes, please.
Is there a way to see where your program is stopped if you don't remember? Like
BT.
you deleted that first breakpoint where we stopped, and you haven't continued since.
Where
then?
the program stops, BT.
Oh, okay.
BT tells you where the program stops. And the program always stops on frame 0. That's the top frame. Right? And if this function finishes, let's say this array sum function finishes, you go back to a coder, the coder becomes frame 0. Does that make sense? So program always stops at frame 0. Because frame 0 keeps changing as you push or pop. But always frame 0 is the place where the program stops. Anything else? Okay, I also want to talk about some mysterious numbers here. Remember, on Tuesday I said every time you call a function, yes, you want to say something?
We talk about it from the concept.
Yes. So that function, every line in your program corresponds to some part of a memory. You don't have the control of that part of the memory. That's controlled by the operating system. But every time you run a program, the operating system will give every line a number. And that is the number corresponds to that particular line of code. So when I say, when you call a function, the line after that function code will be put into a call stack. Is the number after this line. So let me maybe draw a picture, it will be more clear to you. I'm going to
But the integers, the variables that are inside that line, they hold a different memory, right?
That's correct, but that's correct. Okay, so you have your program, and then let's say you have line 10, you call a function 1, and I said when you call a function, then the call stack will remember line 11, right? Because that's the place where the program should continue after the function calls. Right, that's what I said on Tuesday. When you actually run a program, it's not going to store 11. The operating system will map 11 into another piece of memory, and that has number that will be put here. So you will, in the call stack, you will not write 11. You will write some strange number. And that number is a mapping between line 11 into another piece of memory, and that is put into a call stack, and that is this number. Every line in your program has a number given when the program is running. That number can change. Very likely will change if you run the program again. But this number corresponds to line 30. And this number corresponds to line 48. That means start the program in
Why
GDB.
there's no number in the array sum?
Because it's a top, it's currently top. This way will remember where it comes from. Remember I said you will push the line number into a call stack. But it doesn't really push the line number, it pushes that number. Because there's a mapping during execution time. So for this, when I run this program right now, line 30 corresponds to that number. Line 48 corresponds to that number. If you want to start the program, the command is kill. That will start the program. If I run the program again, you'll see the numbers are different. Well, actually, they are the same right now. Not always, but sometimes they are different. This is actually what is stored in the call stack. It's not 30, it's not 48, or 31 or 48. That number is the number actually stored in the call stack. There was a question. Yes?
Over here, the array is equated to a number as well. That would be the address of the array? Or
Yes, this will be an address. That will correspond memory location. We'll talk about that a little bit later. But here I want you to understand what this means. This means the number of that particular line. Okay, any more questions?
How many bits or bytes does one line hold?
You mean how big this is?
Yeah.
Depends on the machine. If you are running a 32-bit machine, this will be 32 bits. If you are running 64-bit machine, this will be 64 bits. And you may have other machines with different address space. Some machines have 48 addressing space. That will be 48 bits. Yes, please.
Are those numbers representing the breakpoints, or?
They are the line. They correspond to a line number. But as I said, when you run a program, operating will have a mapping between the line number and that memory location. So they do not represent the breakpoint. If you want to see the breakpoint, you want to use info B. And this number corresponds to line 7. And this number corresponds to line 41. Does anybody know why there's a mapping here? Why doesn't operating simply give 41? Why doesn't operating simply give 7? Does anybody know why?
Because you might run programs from a different source, and they might have same lines.
Okay, you are pretty close. Suppose I create another terminal. So I go here, I create another terminal, and I can run the program again. Maybe I should try that.
Yes, almost same.
But
Okay.
let's see. In this case, they are the same. Not always they will be the same.
But why are they same? Isn't it gonna overlap?
Because I run in the same program. That means
If you run different ones?
if I run different programs or I make some changes, then this number may change. So this is a way for operating system to make it more general, so you can run the same program multiple times, and each one will have its own memory space. That's the reason it doesn't remember 30 or 48. You will remember that number after the mapping. Okay, any more questions? Did I confuse you or I teach you something meaningful? What do you think? Does this make any sense to you? Okay. All right. So after we understand this, now there's still a lot of things in the code stack, as you can see. We'll talk about that one by one. Okay. Well, let's first talk about the return location after the function call. The next thing I'm going to talk about is what happens if you have a function that takes argument. So suppose I have a function, let's say the function does not return anything, so I have a void. And the function, let me use f1, I say integer a, integer b, and I have something inside. For the time being, let's not worry about what's inside. The function simply have two, we call this will be argument. When programming language was designed in the 50s, guess who designed the programming languages? Physicists, mathematicians, or lawyers, or historians? Who do you think designed the programming language in the 1950s? Mathematicians.
Yeah.
So they were thinking about computers should look like mathematics. They will say a function look like x equal to f(1,3), and f will be a function, right? You have learned functions in high school. And this will be called argument. So that's the programming model we have. Functions have arguments. Right? You may write something like f of n equal to n squared plus 3n plus 5. Something like that, right? When you were learning functions in high school. So that's the design thinking behind in the 50s when people started designing computer languages. So let's consider a function. Now this function will actually give you a variable back. We'll talk about that in a moment. For now, let's consider a function that does not return anything. And for now, I don't care what's inside. I just want to worry about a function with argument, one or more arguments. When you have a function with argument, I already said last week, Tuesday, and I also said again today, when a function is called, the location after this call is pushed to the call stack. So if somewhere you call a function, let's say f, you give a number, let's say 7, and this corresponds to line 19. In your call stack, you'll push line 20 to your call stack. I said actually it's not 20, it's something the operation will change. But for our purpose, our understanding, you don't need to remember that very long number. Just remember line 20 for our understanding. So that's first rule. When you call a function, the return location is always pushed to call stack. There's no exception. When the function returns, when the function finishes the top, we call this a frame. Currently, this frame has only one thing inside. We'll add more things in a moment. When a function finishes the top frame, is popped. And that number is used for the program to know where the program should continue. In this case, continue from line 20. So that's the first part of the frame. This always happens. Every time you call a function, your frame always has at least a location for the program to continue. Now the following things will be depends on whether the function has additional things. So if the function has an argument or more arguments, then the top frame will store the argument or arguments, depends on how many you have.
Does it keep in the order or all of them at the same frame?
They'll be in the same frame. So let's start with 1. Suppose I have a function. Again, I don't care about what it returns. I only worry about the argument for now. And somewhere, let's say in the main function, I call a function and give 7. And suppose this is 919, it will be 920. In the call stack, I will put line 20, and I have a symbol set n corresponds to this n, and then I have a variable 7. This will be symbol. I only draw to here. Okay. This will be variable. If the function has more than one argument, then we will put more arguments there. Let's say I have a function 2, integer a. I use integer as examples. You can have double, you can have character, you can have float, b, integer c. Suppose f2. Then I call a function. Let's say I'm in line 54. I call function 2. I give 1, 2, minus 9. And line 55. So in my call stack, will look like the following. Of line 55. That's the place where the program should continue. I have A, B, C. And this will be 1, 9, 1, 2, minus 9. This will be the symbol. This will be the variable.
Oh, so they're not in the same frame?
They are in the same frame. This one will be a frame. Your frame now has more information.
Okay.
Yes, please.
All the variables are going to be stored on different okay, so how does it know that A, B, and C are part of the same frame?
How does it know? GCC knows. And if you want to know how to do that, take compiler.
Does the order of ABC matter?
Okay, does the order matter? Not really, because GCC is free to reorder them if GCC wants to. And for you, you don't care because you use ABC. So if it happens B is above C, you don't care. But for our understanding, when we draw the picture, for our understanding, I'm going to draw this order. The first one will be at the bottom, second one will be above, third one will be above. But it doesn't really matter in a real program. Since you don't know the order, you just use ABC.
But we know when we use the variable. Like,
how do you know? You know A is 1, B is 2, C is minus 9. How do you know A is above B or A is below B?
shouldn't we put that in the function, like the calculation? A equals to B plus C. In that case, we use B first and then C.
If you say A equals to B plus C, GCC knows where to find ABC. You don't need to know. So if A happens to be above B, GCC knows. It's,
Okay.
it has certain rules to decide which one should be above, which one should be below. You don't need to know. Of course, if you take compiler, then you have to decide. Okay. Any questions on this side? Seems to be more questions from that side. So I hope I'm not ignoring people on this side. Okay. Any questions? You ask a lot of questions. That's great. Anybody from this side have questions? So now, you know, for every encode function, the return location, that's a line number, is always in the frame. There's no exception. And the second thing is, if the function has argument, you can write the function without argument. It's not clear why you would write the function without argument, right? It's not clear why. Because what the function do should depend on how you give to the function. So it's not clear why you would write a function without argument, but you could. If you write a function with arguments, then the arguments will also be in a frame and will be pushed to the call stack. Let me just finish a few more sentences I will answer. And when the function finishes, so it does whatever you need to do. When the function finishes, the top frame is top. Notice I say the top frame means everything here is gone. Everything. Okay, what's your question?
What if one of the function arguments is like another function? Does that make a frame or something?
If the function argument is another function, in that case, in C language, that's actually how to handle that depends on language. In that case, the C language is actually pushing an address correspond to that function.
So how does it look in the frame? Is it
That way, in that case, the function is basically access to a pointer, and that pointer will also be pushed to the frame. We'll talk about pointers a little bit later. Okay, so you are pretty far ahead of me. For C, the way to call function inside a function as an argument is to give a function pointer. And that function pointer is an argument. Therefore, it will be treated in the same way. Okay? So this is important to know everything in the frame will be popped. Any questions about this so far? Yes, please.
What if I put an array in my function argument?
Array will be handled by pointers. We'll talk about pointers next week. Okay? Any other questions? Now let's consider a situation a little bit more complex. Let's say I have a function f1. A function f2. I intentionally give the same name for the argument. And in my main function, I will call f2, that's a 2 and a 6. So let's say consider this one correspond to line 24, so this one will correspond to line 25. And this correspond to line 91, so this one will correspond to line 92. Okay. So based on the rules I just mentioned, main function, first you need to understand main is the starting point of a program. The program always starts from main function. That's true in C. That's not true in C++. In C++, your program may not start at the main function. But since this is not a course on C++, I won't get into detail. In C, this statement is true. Main is the starting point of your program. So main will be at the bottom of your call stack. The call function F2, based on the rules I mentioned, in the call stack you have a line 91 and 92. I need to zoom out a little bit. Then you call function F2. You have A that corresponds to 2. The value is 2. You have a B, the value corresponds to 6. This will be a frame. And for this frame, I'm called frame of F2 because I'm calling F2 right now.
Are they all, including the line 92, are they all in the same frame?
Is it in the same frame? Yes. That's a frame of F2. When I call a function, I will have a frame for that function call. Inside function F2, I'm going to call F1. When I call a function, I have line 25. Every time I call a function, I will push the place the program should continue after the function call into the call stack. Function call happens at the line 24, so I push line 25 to the call stack. Then I have a argument A. This will be A plus 5. So this A plus 5 will be 7. How do you get that? It will be A plus 5. A current is 2, plus 5 will be 7. This will be 7. B will be, this B minus 9 will be minus 3. This is another frame. This is a frame of F1.
Does it still pass the A and B's there?
Which A and B? Okay, now we call it A1, B1, A2, B2. They are called AB, but I want to distinguish them as 1 and 2. Which A and B are you talking about?
In the F1, actually.
Hold on just a moment. Yes, hold on just a moment. I will explain why we have A and B. Yes.
Is the new value of A, it's 7 in this case, is it actually calculated by reading previous A out of the call stack? Or
yes.
Okay.
When you call a function, before you enter the function, you will calculate A plus 5 will give you 7. You will calculate B minus 9 will be minus 3.
So it reads it out of the call stack?
We will read from the top of the call stack.
Okay.
Okay. Now I know many of you have confusion. What's A and B? Is that right? Do you have confusion about A and B? Kind of. Do you have confusion? It's not your fault, because everybody gets confused. And what happens in the computer is, inside the computer, there is no A or B.
Which A and B are in the line 9, in the bottommost frame?
There's no A and B.
Well, why did you write there?
Let me continue, okay? There is no A and B. A, B are for human. Computers know address and value. Computers does not know symbol. So there's no such thing of A and B inside of your computer program.
Can you put equal sign there?
There's no.
Because
you need to
I thought
understand
there
is no A and B. Computer does not know A and B. GCC take out A and B completely. In your when your program gets compiled from your C code to executable, A, B are all gone. There's no such thing as A, B. of course, when you need to debug, there's a mapping table back. But computer programs does not have A and B. Yes.
Will we keep track of address on the call stack, or?
Okay, that's the next moment. Next thing is computer knows address. So what the computer will do is computer will translate AB into address. The GCC will map A, B, and all symbols to address. And GCC plus and with operating system will guarantee addresses are all different. That's guaranteed unless there's a bug in the operating system. So what does this mean? I know we are running out of time. Is inside the computer, there's no A and B. They will only correspond to address. So I have a symbol. I did not write address. And variable. GCC will take AB and convert to address. And just for our convenience, I'm going to call this address 100, address 101, address 102, address 103. For the time being, I'll talk a little bit more about how addresses are given. Yes, there's a question. Go ahead.
So is each function frame? Like is each function frame? So you go to the next function, there will be a new frame.
Yes, every time you call a function, a new frame is pushed. Every time a function finishes, that top frame is popped. Always. There's no exception.
So if you call 5 functions, which means you will have 5 frames.
Do you call? Okay, depends on how you call the functions. If you call F1, F2, F3, you push a frame for F1. F1 finishes, that frame is popped. You push the frame for F2, F2 finishes, that frame is popped. So in that case, you have only one frame at a time. But if you say F1, inside F1 you call F2. Inside F2 you call F3. In that case, you have one frame for F1. You have one frame for F1. F1 calls F2, the frame for F2 will be on top of F1. Because when F1 is not done yet, right? You may have something after F2. You may have something before, after F3. So now your F3 is pushed. So in this case, F1 calls F2, F2 calls F3, then you have 3 frames.
And then at the next function, it will pop up.
If F3 finishes, then this frame gets popped. Then you go back to F2. You may have some more work here, right? And you do whatever F2 needs to do, then after F2 finishes, that frame gets popped. Yes?
So when you return a value, does it manipulate?
We have not talked about return value yet. So until they introduce a concept of a function called, after function called the return location, where the program should continue. That's this line number. And today I talk about argument. And on Tuesday, I'll talk about local variables and the return variables. Okay. Yes.
I have one question.
Yes.